Hey everyone, and welcome. Today, we're tackling a super important topic from 3D geometry, finding the shortest distance between two lines. And I promise you, if you just follow our simple game plan, this is going to feel incredibly easy. Jello, let's get started and make this crystal clear.
Picture this. You're playing a game like Valorant or BGMI. You're running on the ground, and an enemy player is moving on a zip line way above you. You're both moving in straight lines, right? So the question is, what's the closest you'll ever get to each other? That is exactly the problem we are solving today. But instead of players and zip lines, we'll be using the language of math, vectors. So let's jump in.
So, in this 3D world, whether it's in a game or in our math notebooks, there are only three ways any two lines can exist relative to each other. Just three. Understanding these three possibilities is the first, most crucial step.
First up, the easiest one, intersecting lines. Just think of two friends giving a high five. Their arms are the lines, and where their hands meet, that's the intersection. So, what's the shortest distance between them? Ari, it's 0. They're literally touching each other. Simple as that.
Next, we have parallel lines. The classic example everyone knows is railway tracks. They go on, forever. Always the same distance apart, but they will never, ever meet. The shortest distance here is just that fixed perpendicular gap between them.
And now for the main event, the one that's most important for your exams, skew lines. This goes right back to our Valorant example. You're on the ground, the enemy is on the zip line. Your paths aren't parallel, are they? But you're also never going to crash into each other because you're on different levels, or, in math terms, different planes. Most exam questions are about these guys.
This little table here puts it all together perfectly. It's your quick revision cheat sheet. Intersecting lines? Yes, they intersect. Distance is 0. Parallel lines? Yes, they're parallel. Distance is some positive number. But look at skew lines. Are they parallel? No. Do they intersect? No. This is the key difference.
Okay, listen up, because I'm about to give you the secret weapon. The number one mistake students make is they see shortest distance and they immediately jump to the big, complicated formula. Please don't do that. We have a master checklist, a simple game plan that will save you every single time.
Here it is. Before you even think about a formula, you must follow this checklist. Step 1, and always step 1, check if the lines are parallel. Just look at their direction vectors and see if the ratios are the same. If they are, great, we use a very easy formula. If they're not, then you can be pretty sure they're skew. This checklist is your path to full marks, I'm telling you. So let's follow our checklist. What happens if you do step 1 and find out, hey, these lines are parallel? Well, good news. You get to use a special, much simpler formula.
Look closely at this formula. Notice something? There's only one b vector. Just b. Why is that? Well, because parallel lines point in the exact same direction, right? So they share a common direction vector. This makes the whole calculation way easier.
Don't let the symbols confuse you. All this formula is really saying is, first, find the vector connecting a point on the first line to a point on the second. That's your a2 minus a1. Then, take the cross product of that vector with the common direction vector, b. And finally, just divide by the length, or magnitude, of that direction vector. That's all there is to it.
Okay, but what happens in most exam questions? You'll do your step 1 check and find that the lines are not parallel. And that's our cue to bring out the main formula, the one for skew lines.
Now, I know what you're thinking. This looks long and complicated, but I want you to stop seeing it as one big, scary formula. Instead, think of it as a recipe with a few small, easy steps. We just follow the recipe, and the correct answer will pop out at the end. You can totally do this.
So, let's break down that recipe. Step 1, subtract the a vectors. That's easy. Step 2, find the cross product of the two different b vectors. We know how to do that using a determinant. Step 3, take the dot product of the two new vectors you just found in steps 1 and 2. Step 4, find the length, the magnitude of the cross product vector from step 2. And the final step, step 5, just divide the number from step 3 by the number from step 4. See? It's not one hard problem, it's 5 easy little calculations.
Okay, enough theory. The best way to learn math is by actually doing it. So, let's do a full walkthrough with an actual example right out of your NCERT textbook. We are going to apply our master checklist from the very beginning to the very end.
Here's our problem. We've got two lines, L1 and L2. Okay, first things first, let's identify all our parts. For line L1, A1 is I plus j, and the direction vector B1 is I minus j plus k. For line L2, A2 is 2i plus j minus k, and the direction vector B2 is 3i minus 5j plus 2k. Perfect, we have all our ingredients.
Now time for the master checklist. Step 1. Are they parallel? Let's check the ratios of the direction vectors b1 and b2. For the I components, we have 1 over 3. For the j components, we have -1 over -5, which is 1 over 5. Hold on, is 1/3 equal to 1/5? Absolutely not. We don't even have to check the k components. We can stop right here. The conclusion is clear. These lines are not parallel.
So because our checklist told us they are not parallel, we know exactly what to do. We're going to use the main formula, the one for skew lines. We've chosen the right tool for the job. Let's get to it.
All right, let's start cooking. Step 1 of our recipe is finding A2 minus A1. Let's subtract component by component. For the i's, we have 2 minus 1, which is 1. For the j's, we have 1 minus 1, which is 0. And for the k's, we have -1 minus 0, which is -1. So our result is I minus k. First part, done. Now for step 2, the cross product. Beta, this is where you need to be super careful. A tiny plus or minus mistake here can mess up the whole answer. We set up our determinant. For I hat, it's -1 times 2 minus 1 times -5, which is -2 plus 5, so 3. For j hat, remember that minus sign. It's negative of 1 times 2 minus 1 times 3, which is -2 minus 3, or -1, so plus 1. And for k hat, it's 1 times -5 minus -1 times 3, which is -5 plus 3, giving us -2. So our cross product vector is 3i plus j minus 2k.
We're almost at the finish line. For the top part of our formula, the numerator, we need the dot product. That's 3i plus j minus 2k, dotted with I minus k. We multiply the matching components. 3 times 1 plus 1 times 0 plus -2 times -1. That gives us 3 plus 0 plus 2, which is 5. Now for the bottom part, the denominator. We need the magnitude of the cross product. That's just the square root of 3 square plus 1 square plus -2 square, which is the square root of 9 plus 1 plus 4, so root 14.
And now for the final result. We just put our pieces into the formula. It's the absolute value of the dot product, which was 5, divided by the magnitude of the cross product, which was root 14. So our final answer is 5 by root 14 units. And that's it, full marks. See, it was just a sequence of simple steps. Okay, awesome job. Let's just do a super quick final recap of our game plan. This is the one thing you absolutely must remember for your exams. The main takeaway is this. Do not just see a question and blindly start using a formula. Always, always, always start with the master checklist. Step 1, check if the lines are parallel. It takes just 10 seconds. If they are, use the simple formula. If they're not, then you confidently use the main formula for skew lines. This one habit will save you from making the #1 mistake and losing easy marks. So I'll leave you with one final thought. The next time you see a shortest distance question in a test or exam, what is the absolute first thing you are going to do? That's right, you're going to check if they are parallel. You've got this. This topic is no longer difficult. Keep practicing and you're gonna ace it for sure.